Good morning, everyone. Today we're looking at Unit 4, Lesson 2, Solving Problems Using Sine and Cosine Law. So in yesterday's lesson, we talked about those primary trig ratios, and we use those primary trig ratios when we're dealing with right triangles. But we need something when we're dealing with non-right triangles, or what we call oblique triangles. So the primary trig ratios can only be used with right triangles. If we have a non-right triangle, which we call an oblique triangle, we use either sine law or cosine law, or when we're solving for an entire triangle, we might have to use both laws. So let's first take a look at sine law. So we use sine law to calculate an unknown side if two angles and a side are known. So for example, if we knew angle B and angle A, and then we knew one of the side lengths, so say we knew side A, then we would use a sine law. And we're going to talk about why that is in a minute. So we can use sine law when we're trying to find a side or when we're trying to find an angle. So used to calculate an unknown angle if two sides and the angle opposite one of the sides is known. So sine law is all about matching up our angles and sides. So in sine law, we look to kind of make an angle side pair. So we would say that side A corresponds to angle A, and side B corresponds to angle B, and side C corresponds to angle C. So we're always going to look for a side angle pair to use sine law. And this is why, because sine law states that the ratio of corresponding angle and side lengths is proportional to another pair of angle and side lengths. So what I mean by that is if we're trying to find a missing side, we'd say that side A over sine of angle A is equal to side B over the sine of angle B, which is equal to side C over the sine of angle C. All right, those angle side pairs create a ratio that's proportional to the other angle side pairs. So that's what sine law states. So if we're trying to find a missing side, we put the side length on top of our ratio. All right, if we're trying to find a missing angle, we would put the sine part on top. So we would say sine of A over side length A is equal to sine of angle B over side length B is equal to sine of angle C over side length C. So when we're trying to find a missing angle, the angle is on top. All right, so let's try this with an example. So if P equals 55 degrees, so that's angle P, and side length P equals 15 centimeters, and angle A equals 83 degrees, solve triangle PAT. So let's draw triangle PAT first. So we have triangle P, A, and T. Let's just try to draw that a little straighter. So it says angle P is 55 degrees. I'm going to label angle P 55 degrees. It says side length P is 15. So remember, the side length is going to be across from that angle. That's going to be 15 centimeters. And angle A is 83 degrees. So it says solve triangle PAT. So when it says solve the triangle, it means find all unknown sides and angles. So I'm going to start by trying to find that angle side pair. So I have an angle side pair here with my p's. If I was wanting to set up a proportion, I could look at side A, and then I'd have to pair that up. Sorry, I'd have to pair up angle A with side A. So we're going to use the setup to find a missing side. So we're going to have a couple of things we have to solve for, but to start we're going to find side length A. So we're going to say A over the sine of A is equal to, in this case, P over the sine of P. All right, and in this case we don't need all three ratios. We're only going to ever work with two ratios at a time. So for this setup we don't need the ratio for T. I'm only going to work with two angle side pairs at any given time, so we don't need T for this one. So if we plug in what we don't know side length A, so we'll just leave that as A. But the sine is going to be of 83 degrees, that's my angle A. And then side length P is 15 over the sine of angle P, which is 55. So now I'm going to multiply that sine of 83 up to the top, so we're going to have A equals 15 times the sine of 83 all over the sine of 55. So if we calculate that, we should find that A is equal to 18.2 centimeters. Make sure you're comfortable using those sine, cosine buttons on your calculator. All right, that's great. So we found angle A. So that's one of our unknowns. The next most easy thing to find would be angle T. Let's try to find angle T. So again, we know that the sum of the interior angles of a triangle is 180 degrees. So if we want to find angle T, we can just subtract from 180 the angles we already know. So we'll have 180 minus 83 minus 55. So angle T is going to equal 42 degrees. So we have side length A, we have angle T. Now we just need side length T. So we're going to set up another sine law ratio. So we need to find the side length of T, and that's going to be divided by the sine of the angle opposite it, which we just calculated was 42. We'll just write a 42 degrees in our triangle too, so we can see that we have another side angle pair that we've created here. And that's going to be my little t across from it. So t over the sine of 42 is going to equal, and I would always use the ratio of the sides and the angle that was given to you, if you have it, instead of one that was calculated, because you know that to be the most accurate. So if you have a side angle that's been provided to you in the problem, use that when you're calculating unknown values. All right, so I'm going to multiply that sine of 42 over to the other side. We'll have 15 times the sine of 42 all over the sine of 55. All right, and if we calculate that, we should find that T is equal to 12.3 centimeters. So we found all three of our unknowns right there. All right, so that's the idea behind sine law, that sine law uses the ratio of side angles that are corresponding with each other, and it's proportional to the other side angle pairs in the triangle. Let's look at when we use cosine law. So cosine law is used to calculate an unknown, as you can imagine, angle when you are given all three sides. And this will sometimes be referred to as side, 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 or SSS. Those all mean side. right? Side, side, side. So that's cosine law. It can be used to find an angle, or it can be used to find a side when you are given two sides and the contained angle. Two sides and the contained angle. This sometimes is referred to as side angle side. So if I had a triangle, which we'll look at on the next page, but if I had a triangle, and I'm talking about side angle side, if we had triangle A, B, C, and we labeled our little letters where they went. So across from angle A would be side A, B, and C. All right, so when they're saying side angle side, they're referring to two sides. So if I was to say angle or side B and side C, and the angle contained between those two sides. So that would be an example of side angle side, where you have one side, and then as I rotate kind of one way around the triangle, I have side, I have angle, I have side, right? So that angle is contained between those two sides. Okay, so the equation for cosine law is a squared equals b squared plus c squared minus 2bc, and then times the cos of A. I'm going to pause and I'm going to write the other formats of the cosine law. So there's the other forms of the cosine law. What's important here is to understand the pattern of this formula. So understand the pattern. If you look at the first setup there, we have a squared equals b squared plus c squared. So I would just point out that the sum of two sides squared is equal to the square of that third side, which we know is another formula called Pythagorean theorem. So part of your cosine law has Pythagorean theorem built right into it. All right, so once we do the other two sides squared and add together, we subtract from that 2 times those same sides that are on the equal sign, on that side of the equal sign, and then multiply it by cosine of the angle that corresponds to the side we're trying to find. So if we're trying to find side length C, we're multiplying it by cosine of angle C. So if you understand that pattern, you can set it up for any triangle. So let's look at an example for cosine law. So we're given triangle HAT. All right, and it says that side length H is 15 centimeters. Side length A is 12 centimeters. And side length T is 17 centimeters. Oops, let's just write side length T. All right. It says to find angle T. So if we're trying to find T, we're going to set up the cosine law using using that little t. So that means that if I was to write the cosine law, it'd be t squared is equal to the sum of the square of the other two side lengths. So a squared plus h squared. And you're going to minus from that 2 times, again, those same side lengths. So a times h times the cosine of the angle that corresponds to the side length we're trying to find. So times the cosine of t. Now we're trying to find angle t, so we're going to have to rearrange for capital T, which represents your angle, right? That's our angle. So we're just going to start moving some stuff around. So I'm going to subtract this t squared over to this side of the equation, and I'm going to take this whole part here, this minus 2 AH times the cosine of t, and I'm going to move that over to this side of the equation. So if I move that minus 2 AH times cosine t over to the left side, that's just going to be moved over by adding it. So I'm going to have a positive 2 AH times the cosine of t is equal to a squared plus h squared. And then I'm moving this t over to the other side. So that's going to move over by subtracting it to the other side. Okay, so now I'm going to divide both sides by that 2ah. I'm going to move that 2ah over to the other side. So all we're going to have left then is cos of t is equal to a squared plus h squared minus t squared all over 2ah. All right, well now I'm going to back this up a little bit. Now I need to get rid of that cos. So to get rid of that cosine, or to get t all by itself, I'm going to take the cos inverse. I'm going to take the cos inverse, which we write as cos to a power of -1. So let's just do this. Let's take the cos inverse of this side and be equal to the cos inverse of this whole thing. Make sure we can see that's cos to the -1. All right. So when we take the cos inverse of cos, those things cancel each other out, and you're just left with t is equal to the cos inverse of a squared plus h squared minus t squared. So let's go ahead and plug in some values because we're running out of room. So a squared is 12 squared plus h squared, 15 squared, minus my t squared, which is 17 squared, all over 2 times a, which is 12, times h, which is 15. Okay, so if we calculate that, you can plug that whole thing into your calculator in some brackets and then take the cos inverse of it. Make sure you're comfortable using that button. You're going to find the angle T is equal to 77 degrees. Okay, let's look at one word problem together, and then I'm going to have you guys try the last word problem on your own. So it says, Lucy's space shuttle is 35 kilometers from the mothership and 42 kilometers from the space station. So here's Lucy, and she's 35 kilometers from mothership, and she's 42 kilometers from that space station. The angle at the shuttle between the mothership and the space station is that 49 degrees that's in the diagram. How far is the mothership from the space station? So we're trying to find that third side of the triangle. So I'm going to label it X, and we're going to let X represent the distance from the mothership to the space station. Okay, so we have here a side. Let's use a different color. We have a side, an angle, and a side. So side, angle, side means we're going to use cosine law. So we're trying to find that side length x, so let's make sure we can represent that accordingly. So it's going to be x squared is equal to the sum of the squares of the other two sides. So let's just call the other two sides a and b. So we'll say a squared plus b squared. And we're going to subtract from that 2 times those same sides. So 2 times a times b. All of that is going to be times the cosine of the angle that corresponds to the side length that we're trying to find, okay, which is x. So we can just start plugging some stuff in. It doesn't matter which side we choose as a. We'll say that a is 35 squared and b is 42 squared. Minus 2 times that 35 times 42 times the cos of that angle that corresponds with it, which is 49 degrees. So don't forget about your order of operations here. It's very important. We use cosine law, okay, this whole piece underlined here in blue, we need to calculate this all together. Sometimes we want to add or subtract before we do all that multiplication, but that's not correct according to BEDMAS. So calculate this all together. So if I calculate that 35 squared plus 42 squared, we get 2989 minus, and then if I calculate all this stuff together, you're going to get 1928.8135 dot 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 dot. Leave all the decimals until the end. Okay, because if you round too early, you're going to get a very different answer. So leave all the decimals until the end. All right, so we're going to end up with, when we combine those two, we're going to have x squared is equal to 1060.18645 dot 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 dot, right? Leave all those decimals again. And then we're just going to take the square root of both sides, figure out what x equals. So you take the square root, you're going to get 32.6. So then we just need to make sure we answer the question. So therefore, the mothership is 32.6 kilometers from the space station. Okay, so that answers the question of what was asked in the word problem. I'm going to pause the video, read the next example, and try to solve for the unknown in that question. Okay, so there's the solution for the next question. We were asked to find how far the plane is from the tower. So I labeled that with a little j, just to show that it's across from angle J where the jet is. Remember, those correspond. And then I looked to see what I could find. So I couldn't start right away finding that side length J because I didn't have the angle that corresponded with it. But I did have some other side angle pairs. So I used my sine law and I started working to fill in the unknown information. So I used my sine law in step 1 here to find angle P. And again, I used the setup with the angle on top. Because we're trying to find an angle. So whatever the unknown is, that's what we want to put on top when we set up those ratios. I found that my angle P was 40 degrees. And then I used that information to move over to step 2 to find that last angle by subtracting the 2 I know from 180. Once I had that angle J was 72 degrees, I could use that in my last step, step 3, to find that side length J. Again, I set up my sine ratio and I solved for J. And then I found that the plane is 7.7 kilometers from the tower. That's it for your notes for today.